Hi everyone! In this tutorial I will show you how to create a parametric globe valve family in Autodesk Revit. This family will be controlled by a CSV file, so if you don't know how to work with CSV files in Revit, you can watch our other tutorials on this YouTube channel. Let's get started! I will start with opening our PipeEX 2 connectors template, which is, by the way, available for download on our website. And here we'll start with adding a few reference planes for the flanges of our globe valve. Then I'll also change the scale. And we'll adjust the distance between these two reference planes. Yes, like this. I'll actually need a few more reference planes. So this is going to be our first flange. And then, of course, we'll need to create another flange on the left side. Yes, this should be fine. So now we'll add a few more dimensions. First, I'll equalize these two reference planes, and you know what? I will change the scale again. So, to this dimension we can add an existing label, and it will be this label, DN. But first I need to go to family types and set the correct value for this parameter, because this diameter is now too big, and I will set it to 15 millimeters. This should be fine. And then we'll select this dimension and assign this label, this DN and 1 DN label. We'll create a new parameter for this dimension and let's call it D4. And I'll make it an instance parameter. And then I'll click OK. So this dimension here is going to be the thickness of the flange. So I'll select this dimension and assign the existing N1 thickness label. Yes, the only problem is that I'm not quite satisfied with its size. So I will change it to, let's say, 10 millimeters. Yes, it looks fine, and we'll need to add another dimension for the outer element of our flange. In this dimension, for this dimension we'll create a new parameter and we'll call it _th thickness and click OK. On the other side, I will add the same parameter to this dimension, so it was underscore thickness, and of course we'll need to add the end2 thickness parameter on the left side. We can actually use the same parameter, it doesn't matter, and one thickness. Yes. So I think we can start creating our geometry. I will go to Create and select the Revolve tool. So here I will use Rectangular to draw the profile for our Revolve. I'll click the lock icons. And then you need to select the axis of rotation. Or you can also draw it. So this is our first flange, and then we also want to create the outer element. But for this element we'll need a few more reference planes. Also here I want to equalize them first, and then we'll add a dimension. And we'll create a new parameter. It will be D. I'll make it an instance parameter and click OK. So now we can create the outer element of the right flange. Using the Revolve tool again. Again, I'll click all padlocks. And don't forget to draw the axis of rotation. So this already looks good. Now we can continue with the second flange. Also here I will use Rectangular to draw a profile. Let's see what we have created so far. I will go to a 3D view and enable shaded. And then we'll go back to the reference level view. I'll add one more dimension for the width of our globe valve. And we'll call it L. Next, we will create the valve body. So first, I'll go to the Create tab, and here I'll select Extrusion. Then we'll need to draw an extrusion profile and add a dimension. Next, I will select this dimension and make it a diameter. So we need to add a parameter, of course, to this dimension. So I will call it underscore body diameter 1. I'll make it an instance parameter as usual, and then I'll click OK. Now we need to go to the front view. And here you see that we definitely need to adjust the height of the body element we've just created. So first I'll add a few reference planes to control the height of our globe valve and parts. This should be sufficient. And then I'll make them equal to each other. Okay, I can already say that we need to change the scale also in this view. Yes, it looks definitely better. So this is the total height dimension I've created, and we'll call it H1. Then I'll go to family types, and here we'll adjust the value of this parameter. The realistic value for this parameter would be something like 140 millimeters. I'll click apply and OK. I will use the align tool to align its top with the reference plane. Don't forget to click the lock icon. I'll add a few more reference planes for the second body element that we'll create over here. So then let me create a parameter that would be equal to that would represent the module size of this height parameter. I'll create a new label. We'll name it underscore height module size. And I'll click OK. Then I'll go to family types and I'll add a formula for this parameter. Let's find it first. Here it is, height module size. And over here, I will type in H1 divided by 8. Now you see that this dimension, so this distance between these two reference planes is equal to this module size that we created before. Next, I'll equalize these reference planes. And and we'll go to the reference level view. Here I need to create another cylinder. To do it, I will select extrusion and we'll draw a circle. This time it will be slightly smaller than the first one. And also here I will, of course, create a dimension, diameter dimension, for which will create a new parameter. I will call it underscore body diameter 2. Now we can go back to the front view, and obviously we'll need to change its height. Again, I'm going to use the Align tool to do it. First, I click on the reference plane and then on the bottom of the cylinder, and then I click the lock icon. Now I need to add one more reference plane because I want to have a thin element between this body elements. And for this, since also cylinder shaped element will add a new dimension. I don't want to have too many parameters in my project, in this family, especially when you shouldn't necessarily have them. So I'll simply select the TH label of this parameter thickness. And then we'll use the Align tool again, select the reference plane, then the top of the cylinder, and click the lock icon. Then I'll go to Family Types, and here I want to add formulas for these two diameter parameters, body diameter parameters, and I want them to be dependent on the DU parameter, because since this family will be controlled by a CSV file, so it's important that this body diameter adjusts to the new valve diameter without any issues. So what I'll do, I will copy the name of this and1 DU parameter, and here I will insert it for body diameter 1. I want it to be bigger than the DU diameter, so I will multiply it by 1,3. And for this parameter, body diameter 2, I will also add the diameter, the end1 DU parameter, and I will say Revit that it should be multiplied by 1,1. So it will be slightly smaller than the first cylinder or body element. Alright, I'll click apply and OK. Yeah, something strange has just happened, and it is because we said that these two parameters, and1 DU and body diameter, are linked now, and therefore I need to add a realistic value for this parameter, otherwise it looks quite strange. So for now I will type in something like 19 millimeters, and later it will be controlled by a CSV table. So I would say that it already looks good. So next I would like to continue with body bowl. So first of all, we'll need to add one more reference plane, and then we'll add a diameter, and then we'll add a dimension. For this dimension, I will create a new parameter. We'll call it underscore body wall height. And I'll make it an instance parameter and click OK. Also for this parameter, I want to add a formula because we don't want to have any static elements in our Revit family, because otherwise we won't be able to change the globe valve size. So where's this element? Yes, here it is, body ball height. So this parameter I'll make dependent on the dn parameter. It's not that important, it's just my preference in this case. Let me see, yes, here it is. And we'll say that it will be divided by 3. In the next step, I will go to create. And for this element, we'll use the Revolve tool. I'll start drawing a profile using a simple line. And then we'll use a start and radius arc. Yes, I think something like this would be fine. In this case, I won't add radius for this element because it is unnecessary in this situation. But what I do want to do is don't forget to pick the axis line, the axis of rotation, and then you can click OK. You know what, I'll add one more reference plane because we might need it in the future, and also we'll need it for this spherical section. It is actually simply the diameter of this body element. Therefore, we don't need to create a new parameter. We'll just select an existing one from the list. And it was, I think, body diameter 2, this one. Yes, right. And now we can go back to edit Revolve. And here we'll use the align tool because we want this point to always follow this reference plane. Yes, this should be fine. Now we can click OK. And I also don't think that we added a formula for the TH parameter. No, we haven't done it yet. So let's create a new formula. This time I want it to be equal to the end1 thickness. Or better to say to its quarter, because I will divide it by 4. And then click apply and OK. So next we can go to create, and here I want to create a really thin elements that would be between these body parts or body elements. It will just make our globe valve look better and more realistic. So for this element we'll use the Revolve tool. And I'll start drawing the profile using a line. So here I will create a radius parameter. We'll simply call it R. And for R, we'll need to add a formula as well. So let me find it first. It will be equal to underline DH. No, it actually has to be a little smaller than this parameter, so I'll add -1 for 1 millimeter, and let's see if it works. I will pick the axis line and click OK. I think this is fine for now. Next, we'll continue with the body flange, and I also want to create another element between the body flange and the upper body element. So first I'll add a new reference plane and a dimension. We'll use an existing parameter for this dimension, and it will be the DH parameter. But first we need to create the rest of the body, of the valve body. But first we need to create the rest of the valve body. So I'll add a reference plane to define the center of the flanges. And actually we'll need to do it also on the other side. And I'll repeat it on the right side. Okay, now we can continue. So I'll go to create, and here we'll select the sweep tool because we'll use it for the diagonal body elements. And here I'll go to sketch path. Using the line, I will draw a path. Yes, we'll have something like this. And here again, I will use the align tool. We'll click the padlock. Also here I'll first select the reference plane, and then I'll click the point that should be locked and click the padlock. Next, I will add an angular parameter. Well, actually we need to lock this angular dimension, but I won't do it now because I can already say that this angle is too small, and we first need to add a CSV file to our Revit family, and then having the realistic values for all parameters in this family, we'll see how the angle will change and will lock the realistic angle. So this now doesn't make sense, so I won't lock it. We'll simply click OK, and then we'll continue with the profile of our sweep. So I'll click Edit Profile and we'll go to the left view. So this red point is the center of our profile. I will use the circle. We'll add a dimension and I'll make it a diameter dimension. For which we'll assign the U label. Yes, this one here, and one DU. Then I'll click OK. No, I won't save the project, and now we can go to 3D view. So this is what it looks like. And we need to create the second diagonal body element. So I will go back to the front view, and here again we'll go to Create, select Sweep, and Sketch Path. And again, I will start drawing in the center of the right flange, and we'll finish in the center of the upper body element. And then I'll hit Escape, and we'll use the Align tool to lock the end and start points of this path. No, it's this we don't need to do, but I will lock it on the other side. Okay, now we can, yes, again, I almost forgot to add an angular parameter, angular dimension, so yes, and also here I won't lock it yet because it doesn't make sense for now. But what I will do, I will click OK, and we'll click Edit Profile. One more time, I will go to the left view, open this view, and create another circle. Now we can continue with the body flange and with the bonnet of our globe valve. I'm now in the reference level view, and here in the Create tab, I will use the extrusion tool. For the body flange, we'll first add a few reference planes. And we'll add dimensions. For this dimension, we'll add a new parameter, and we'll call it Bonnet width. We'll make it an instance parameter and click OK. For the other side, we'll assign the same parameter. And then I will go to family types, and here I want to add a formula for this parameter. It was this one, and we want it to be bigger than the body diameter 1. That's why I'll copy and paste the name of this parameter, and then we'll say that it should be multiplied by something like 1.3. I'll click apply and OK. Then I'll go to create, and for the body flange we'll use the extrusion tool. So first I'll draw a rectangular. And we'll also use the fillet arc tool to round the corners. So let me, add a dimension, of course, and maybe we'll change the scale again. So I will do it for all corners. And for all of them, we'll create a new parameter. Let's call it Bonnet radius. And in family types, we will make it equal to the bonnet width divided by 10. So we want it to be 10 times smaller than the width of this element. Yes, apply and OK. I'll go to front, and here you see that, yes, at the moment this element doesn't look great because it has clearly the wrong height. So what we can do, well, first of all, we'll need to add one more reference plane. So this reference plane, I simply want to be locked between these two reference planes. So it will be a half of our module size. Yes, and for this, so to change the height of this element, I will use a line. I just realized that this thing actually doesn't belong here. It is supposed to be between the body flange and this body element. So what we can do, we can move it. Yes, as you can see, we'll need to modify it. But first we need to add a few reference planes. So it is simply the existing diameter of the valve body element, and we can find it in the list. It was, I think, body diameter 1. And now we can select this element and edit it. I think it would be easier to delete the dimension and this arc that we previously created. So first thing that I will do is I will extend this line and this line over here, and then we'll use the align tool. Take the padlock. Alright, now we can continue, and we'll continue with the bonnet of our valve. So actually we can create a copy of this element. And then adjust its position. Okay, I see what's the problem. I was surprised that it doesn't have the same height as the lower element. So now we can add this parameter th, and you will see that it has the same size as the lower element. The only thing we need to do is we need to align its top and bottom with the right reference planes. And then I will select the bonnet and go to reference level. Here we can isolate this element, because this way it will be easier to work with it, and I want to make sure that it has the same parameters as the element height mode. So let's see. Yes, so it's the right element I selected, and we want also this element to have this width, so we need to align its sides with the reference plane. And let me see, yes, was the width. So I'll click on reference plane and again on the bonnet size, and we'll lock them. Let's go to a 3D view and see what we have created so far. Yes, it looks good. And we can continue. Now let's create a second thin element between the body parts. I'll select Revolve and we'll sketch the profile. Let's click the lock icons and then we can round this corner, only this one corner. Our line is too short, so we're getting a message that we need to have a smaller radius. Okay, so we'll create a dimension and let's create a new parameter. Oh wait a minute, we probably already have it. Yes, it's this one. So let's see if it's not too big for creating a revolve. Okay, and no, it's fine. Next, we'll create the stem of our globe valve. To do it, I will go to the reference level view, and here I will select extrusion and will draw a circle right in the middle of our globe valve. I'll create a dimension and we'll add a new parameter. So I will start with underscore and then I will call it stem radius. Okay, and now we can go to family types and add a formula for this parameter. Now we can go to front and change its height. So I want the bottom of this element to start somewhere, let's say, on the top of the body flange. So using the align tool again, I will align it with this with the top, this element, and I want it to end. I don't even know. Maybe we need to add another reference plane and yes, I think that it should end somewhere here. No, I think it should be even shorter than we made it. Yes, remove constraints and then pick the padlock. So next thing we're going to do is we'll create the yoke of our valve family. I can do it from the front view. For this element, I will need new reference planes. It is going to be the width of our yoke. So we'll add one more dimension and we'll create a new parameter. It will be called yoke width. I'll go to create, select extrusion, and here we'll draw the front our yoke. Okay, so I'll delete this line because we got an error message. And I'll draw two lines. It will get a new parameter. Let's see if we can use the existing one. Maybe the thickness parameter. Yeah, I think it's a bit too small, but it's fine for now. Maybe we'll change it later, we'll see. Yes, and so now that we have these dimensions, we can align the rest of the lines with these reference planes. I noticed that I forgot to click equal. And we can continue now. So here, for this element, we'll need to add a few radiuses, the inner radius and the outer radius. And we'll add a new parameter. So let's call it underscore yoke inner radius. And then we also have the outer radius here. It's this dimension and this one. Will be yoke outer radius. So now we can go to family types and add formulas. So what we've just created, it was the yoke width parameter, and we want the yoke to be more narrow than the bonnet. So I'll copy the bonnet width name, and here we'll paste it, and we'll say that it should be multiplied by 0.7. For the outer radius, we'll use the yoke width this time. And we'll say Revit that it should be divided by 3.2. And for the inner radius, we'll use the outer radius and divide it by 4. Apply, OK. And then we'll go to the left view, and we'll need to, yes, obviously we need to set the correct thickness of this element to define the right thickness of this element. So let me see. I'll add new reference planes. Let's create a new parameter for thickness. So we'll call it yoke thickness. And this parameter will be equal to d divided by 5. Let's go to a 3D view and see what we have created. So let's add one more reference plane, and we'll lock it between these two reference planes. Next, we can go to reference level, and here we'll create a new cylinder using the extrusion tool. So I'll draw a profile. So yes, I'll create a diameter or a dimension with the radius dimension, and we'll create a new parameter. I'll call it Yoke upper cylinder radius. It actually doesn't matter how you call it, it's only important that you can find it later when you work with this Revit family. Yes, fine. And we can go to front. And here we need to adjust its height. So I wanted to start, let's say, over here. I'll click the lock icon. It's like this, and then I wanted to end somewhere over here. And don't forget to click the lock icon. Okay, now we can go to family types, and also to this parameter we'll add a formula. But I think it's better to do it later. For now it's enough to set the value to 6 or 8, something like this. And yes, it looks actually not bad at all. So next I'll go to family types. And here I'll go to manage lookup tables. We'll delete the existing table and import a new comma-separated value file. It is called the globe valve. I'll click OK, and now we need to find the lookup tab parameter under text. And here I will type in the exact name of this CSV file. And then we'll start filling in the values of these parameters. So the pressure rating I will set to 25. I'll copy the formulas in this case, and I'll paste them. So it was facing end 1, and for end 2 I can simply edit the name. Yes, I made a mistake. Actually, this parameter should have the name D. So I'll add underscore, and otherwise it won't be possible to rename it now. And this parameter D we also need to rename, and yes, I'll say that it's D4. Alright, and now this is our D, underscore. Yes, good. By the way, we'll upload this CSV file comma-separated value file to our support materials on our website, so don't worry, you will be able to find everything you need. I'll create one more parameter because it's, I think, the only parameter that is currently missing in our project. And also for this parameter, I'll add a formula, size lookup formula. Okay, so Revit says it's invalid input. Oh, it is likely small d. Yes, so it is important that you insert only the values that are present in the comma-separated value file. And yes, otherwise Revit won't find it. So the name of this parameter I will also change to d to avoid confusion. So this is it, and we can continue with the Handwheel. But first I want to change the position of this cylinder. I'll use the Align tool and align it with this reference plane. Okay, so you see this element disappeared because we added size lookup formulas, and the sizes of the elements has changed. And yes, you need to play a bit with the values because I slightly changed the value. We had -1 millimeter and I changed it to 0.8 millimeters, and now it works. So the element has been created again. Yes, so you need to carefully check everything out after you edit formulas. So alright, let's continue with the Handwheel. And it's actually the last element that we need to create. I will add a few more reference planes. Then we'll lock them between the existing reference planes. I think they should be a bit longer. And for this dimension, we'll use the parameter that we recently created. We'll create a new parameter and call it Handwheel profile radius. Yes, now we can go to family types, and here we'll use a formula for its value, and should be equal to h1 divided by 16 divided by 2. Okay. Now we can go to create and create a new revolve. Also for this radius dimension, we'll use the same Handwheel profile radius parameter. Then I'll draw the axis of rotation and click OK. So this is our Handwheel. I'll go back to the reference level view and we'll create a new cylinder that will be placed in the center of our Handwheel. So I'll select extrusion and draw a circle. Now I'll go to left. And we'll adjust its position in the view. So first, I'll click the reference plane and stand the bottom of the cylinder. The same I will do with its top. And I'll click the padlock. Next, we can create handwheel spokes. So I'll stay in the reference level view. So I'll go to create, and for the spokes we'll use the Revolve tool. So I'll draw a rectangular. Yes, I actually selected the wrong reference plane. Let's correct it. It is this one over here. That should be the right one, and then I'll click on the sides. Let's click create. But what I haven't done yet, I haven't added a dimension for the spoke thickness. So I'll do it now, and it was this one, profile radius. Yes, we also need to place it correctly. So now I'll go back to reference level view. So now we can continue with other spokes, and I'll need to add another reference plane. Then we'll add an angular parameter. Okay, so let's set it to 30 degrees. And I'll click the padlock. Then I'll create another reference plane for the last spoke. Okay, so then we'll add an angular parameter. Also here I will click the lock icon. so that it always stays in place. To make sure we have 90 degrees, I will add angular parameters and lock them. Let's see, yes, I lock this one. Of course, we need to add a thickness parameter. So it was this one, profile radius. And then I'll go to create and again revolve. So let's create a formula. Let's create a formula for the bulk length parameter. So you see that it doesn't work the way we created the spokes. So now we need to come up with a new solution. So first I'll delete this angular dimension, and I'll also delete these reference planes. We won't need it here. Alright, so this dimension can stay, and this one I'll also delete, and there should be no reference plane here. So let's see again. So I think it looks better now. It starts in the center of our hand wheel and has the right length. Let's check it one more time. So what we can do, we can move it the center. Okay, 90 degrees are locked. Let's try again. This looks better. Yes, I think it's at the right position now. So let's go to front. And here, while the element is selected, I will go to edit work plane, pick a plane, and we'll pick this reference plane. The same I'll do for the last spoke. Also pick a plane, and I'll pick the same reference plane. Let's go to a 3D view. So, and this is the result. Yeah, because we're using the thickness parameter for the yoke element, it is impossible for Revit to create bigger sizes of the globe valve. So we need to select the right parameter. So in this case, we need this parameter to be bigger than, what do we have here, 1.4, so it should be something like maybe like profile radius. I'll change it also here. So handwheel profile radius, this one. So So our family is almost ready. The last thing we need to do is to add pipe connectors. So I'll go to the reference level view. And from here, I'll go to create pipe connector, work plane and pick a plane. Then we'll adjust its position, and I'll set this value to 0. Alright, and the same I'll do on the other side of our globe valve. So I'll go to create, pipe connector, select work plane, pick a plane, and now we'll pick this reference plane. I'll mirror this element. And again I will change its position. In our case, it should be at level 0. And then I'll select the pipe connector and here I'll assign a label to its diameter. It's this one, dn. We can go to a 3D view and see what we have created. Yes, it looks good. And for the second pipe connector, I'll also do this. Also here we can say and to dn. And now our pipe connectors have the right size. Perhaps it would be better to hide them in this view, because now I want to go to family types and we'll check whether our geometry adjusts to the new sizes. So let me start with a small size, 10. Yes, the geometry was created. What if I'll set it to 15? Yes, it's still working. And then we can try another size, 25 for example. Yes, everything is fine. So maybe we can try some bigger sizes like 50. Yes. Also here everything is working. This is what I wanted to show you. This is how you can create a parametric globe valve in Autodesk Revit. I hope this video was useful. If so, please like this video, subscribe to our YouTube channel not to miss our new tutorials, and I'll see you in the next video.